Welcome back. This is an Aleks homework video on calculating the composition of a buffer of a given pH. This is hard, so you have to take it very slowly and you have to be organized in your thinking, okay? Because there's a lot of steps here, but it doesn't mean that you can't do it. It just means that as you understand more and more, you have more and more abilities. So that's why I hope you're watching this video. I hope it helps you. Okay, so you are wanting a pH, but you're given either a case of A or a case of B. So immediately you will think of an equation that relates the pH to a case of A or a case of B, and it's called the Henderson-Hasselbalch equation. So that's the first thing that I think of, is that if I want a pH but I only have a dissociation constant for the acid or base, then I need a relationship between them, and that's what this equation does. The other thing that you need to know is that the Henderson-Hasselbalch only works if the pH is very, very close to your pKa. So if it's very, very close, then you can use this. My thinking is that all these problems will be very close. That's my guess. So first of all, knowing that I'm wanting the case of A to be equal to my pH or very close to my pH, I'm going to take either the case of A that's given or the case of B that's given and find the pK. So the pKb is the negative log of whatever you're given. So the negative log of the case of B in this case, because I'm given a base, you might be given an acid. So you're wanting it to be really close. The pKa, or the negative log of your case of A, needs to be close to the pH in order to use this equation that you really want to use. Okay? Now, if I'm given the base, I can't use the pKa, so I need to use what it's equal to. So the pKa is related to the pKb via the water constant. So your formula, easy formula, and water constant is always 14. So your pKa plus pKb equals 14. All right. So in my case, I have to say, is the pH equal-ish to the pKw minus pKb? That should be pKb right here. Okay. All right. So if it's close, then you can use the Henderson-Hasselbalch, and it should be okay for you. All right. There are two. Of course, they're related to each other. If you're given the acid, your pH equals your pKa plus the log of your conjugate base over your acid. Okay, and remember, your conjugate base is simply going to be whatever your acid was minus a proton. So it's going to go down in charge, and it's going to have one less H. For your base, it's backwards. It'll be pH equals pKw minus pKb plus the log of whatever your base that you're given divided by the conjugate acid, in which case you're going to have to add a proton to it. And so the charge will go up, and you'll have an H there that you didn't have before. All right, so I just put in my information. I took case of B, took the negative log of case of B, got the pKb, and I've got it here, 2.88 something. pKw is always 14. That's a constant. So I checked it. The pH given is 11.38. The pH that I figured out was 11.114. It works. I can use this. So I'm going to use my base because that's what I'm given. You would use your acid if that's what you're given. All right, so I'm just going to start plugging in. My pH was 11.38, it said. pKw is always 14, and then minus my 2.88. And then the constant, remember these brackets, is the molarity. The molarity of the base over the molarity of the conjugate acid. So they gave you the molarity of this dimethylamine as 1.2 molar, so that's 1.2 over and then the concentration of my conjugate acid. Now, that is what I'm actually wanting. I'm really, really wanting that, because if I knew the molarity, then I could figure out the moles. And if I knew the moles, I could figure out how many grams that I needed, and that's what they're asking for. So I do a little bit of algebra, a little bit of ugly stuff, and I do a logarithm, and it's ugly, and I end up with that the molar concentration of this acid is 1.845 whatever, okay, molar. Okay, so there's the concentration of your conjugate acid. That is the 1.2, which was your molarity of the base over the molarity of the acid, and I found its molar concentration. So I have the molar concentration of the acid, so I'm nearly done. That means molarity is moles over liters. If I knew the liters of the buffer, then I could find the moles to put it in, okay? So they give me the liters of it as 125 milliliters, and remember this is moles per liter, so I have to change it into liters. So I end up with 0.081 moles of my base. Okay? So since my conjugate acid is going to have that same amount of moles, we're only just removing an H or adding an H. It's going to be the same. So I'm going to have that same amount of moles for my acid needed. I simply added up all of the molar masses and found that the mass of dimethylamine hydrochloride is 109.598, and multiplied them, got rid of moles and found grams, and then I need two significant digits, so 8.9 grams. So one of the hardest Aleks problems I think I've seen. Okay, so I hope you can get this and nail it, and I hope it's not on your test.